Hello guys, welcome back to my channel. In this tutorial we are going to look at this integral. So if you haven't subscribed to my channel yet, make sure you support my channel by hitting the subscribe button, so I will continue uploading engaging tutorials on integral calculus. So let's start off by using a trig sub. We can let x to be equal to cosine of theta, so dx is going to be negative sine of theta d theta. And the change in limits, when x is equal to 0, we have theta to be equal to the cosine inverse of 0, which is pi over 2. That's cos 90. When x is equal to 1, we have theta to be equal to the cosine inverse of 1, which is 0. Cosine of 0 is 1. Cosine inverse of 1 is 0. So let's take our integral from the x world into the theta world. This becomes the integral from pi over 2 now to 0 of the square root of 1 minus cos squared theta, because x is cos theta, sine inverse of 1 plus cos theta over 2 divided by the absolute value of sine of the tan inverse of the square root of 1 minus cos squared theta all over cos theta, like this. And dx is going to be negative sine theta d theta. There is negative. I can switch the limits and that will nullify the negative, and that will be square root of 1 minus cos squared theta is sine theta plus sine inverse of, I'll leave this one for now, which is 1 plus cosine of theta over 2. I'll deal with that later on. All divided by absolute value of sine of tan inverse of 1 minus cos squared theta in the square root is sine theta over cosine of theta times sine theta in this theta. Sine theta over cosine theta is tan theta, which is pi over 2. So this will be sine of theta plus sine inverse of the square root of 1 plus cos theta over 2, like this, divided by the absolute value of sine of tan inverse of tan theta times sine of theta, the theta. So in the end, you have integral from 0 to pi over 2 of sine theta plus sine inverse of the square root of 1 plus cosine of theta over 2 divided by the denominator simplifies to sine theta, because tan inverse of sine theta is theta, and that will be the absolute value of sine theta times sine theta d theta. This will cancel out, and you are just left with the integral from 0 to pi over 2 of sine theta plus the sine inverse of the square root of 1 plus cosine theta over 2 d theta. So let's tackle this one now. With this one, we know that cosine of theta can be written as cos squared theta over 2 minus sine squared theta over 2. That is using the double angle identity. And we know that sine squared theta over 2 is going to be 1 minus cosine squared theta over 2. So this is cosine squared theta over 2 minus into brackets 1 minus cosine squared theta over 2. So cos theta is going to be 2 cos squared theta over 2 minus 1. So in place of cos theta in our integral, we can just replace with this one, right? So let's switch back. So our integral becomes the integral from 0 to pi over 2 of sine of theta, I'm sorry, plus sine inverse of the square root of 1 plus cosine theta. Cosine theta can be replaced with this, which is 2 cos squared theta over 2 minus 1, all divided by 2, which is here. All this d theta Okay, so this one and this one, this theta. So in the end, we have the integral from 0 to pi over 2 of sine of theta plus sine inverse. 1 and 1 will cancel out, and then we have 2 also cancel 2. So in the end, we have cosine squared theta over 2 in the square root, which is just cosine theta over 2, like this, all the theta. And we know that cosine theta over 2 can also be written as sine of pi over 2 minus theta over 2. From the double angle identity, sine pi over 2 minus theta over 2 is the same as cosine theta over 2. So we can replace that with what is in the integral, 0 to pi over 2 of sine of theta plus sine inverse of sine of pi over 2 minus theta over 2, like this theta. So in the end, we have the integral from 0 to pi over 2 of sine of theta plus sine inverse of the sine of this angle is just the angle, which is pi over 2 minus theta over 2. In the theta. So our integral is now trivial. We are now ready to integrate. Integrating sine theta is negative cosine theta. Plus integrating this is a constant, that is pi over 2 times theta, minus this one is theta squared over 2 times 1/2. You're integrating that from 0 to pi over 2. In the end, what do we get? We are going to have pi theta over 2 minus theta squared over 4 minus cosine theta from 0 to pi over 2. Now let's plug in our limits. So we have pi times pi over 2. So pi over 2 times pi over 2. This is pi over 2 squared times 1 over 4 minus cos of pi over 2. This is the upper limit. Lower limit, what do you get? Lower limit, this is 0. This is 0. And this one is minus cosine of 0. In the end, this is pi over 4 minus, this is pi squared over 4. I'm sorry, this is pi squared over 4. This is pi squared over 4 times 1 over 4, which is pi squared over 16 minus cosine of 0 is, cosine of 90 is 0 minus, so at the end we have plus cosine of 0, which is 1. So pi squared over 4 minus pi squared over 16, that is 3 over 16 pi squared, I guess. Yes, that is it, plus 1. And this should be the value of our integral. So in the end, our integral evaluates to 3 over 16 pi squared plus 1. So that is how you evaluate this integral. If you find this helpful, make sure to smash the subscribe button and give me a thumbs up so I will continue uploading challenging tutorials on definite integrals. Thank you so much for watching this video, and I will see you in the next one. Bye bye.